Our next nonparametric statistic is the chi-square. Chi-square is a very important nonparametric statistic because it can be used in a variety of situations. Here we're going to use the chi-square as a equivalent to the independent t-test. In the t-test, the dependent measure is continuously measured. In the chi-square, the independent and dependent variable are nominally measured. Chi-square has two nominally measured levels. The dependent variable is a categorical variable with two or more levels.
So the example that we're going to use is we have examination performance, and we've categorized people into upper and lower group. The upper group performed better, the lower group performed poorer. Then we want to see if there's a relationship between which group you were in and how you responded to a particular item. In this case, the responses to the item are A, B, C, D, and D is starred, indicating that that's the correct response. So we want to know if there's a relationship between how you performed on the test, better or poorer, and how you responded to this particular item. Our N is 100 subjects.
Here are the results of our chi-square. In the top box, you will find the response pattern to the two groups of students, how they responded to the four possible responses on the item. 47 of the 100 students did poorly on the exam. 53 of the students scored well on the exam.
Notice then that there were 56 students who actually got this item correct. 56 of them, 24 from the poorer group and 32 from the upper group. So is there a relationship between which group you came from and how you responded to this item? That's answered by looking at the chi-square information in the bottom table.
And here we find the chi-square to be 6.131, and that is not a significant difference if you have 3 degrees of freedom.
In other words, there's not a relationship between which group you were in and how you responded to this item. How do you interpret those results? First, recall that D is the corrected response.
So the interpretation is about 50% of the students answered the question correctly, which is what test constructors shoot for. The item did a fair job of discriminating among the good, 32, and poor, 24 students. However, the pattern of responses to all of the possible responses did not turn out to be significantly different for the two groups.
Essentially, what you would like to see is that more people from the better performing group answered the item correctly, and less of those people chose the options A, B, and C, and more of the poorer achieving students would choose responses A, B, and C. We'll next turn to SPSS and illustrate how to conduct this analysis.
As usual, we start with our SPSS data view. We have two columns. In column 1, we have the test performance, and in column 2, we have the response chosen by each of the subjects.
To conduct the chi-square analysis, you go to Analyze, Descriptive Statistics, Crosstabs. We're going to cross-tabulate test performance by item response. We'll put test performance in the rows, that's better or poorer, and the response in the columns, that's A, B, C, or D, with D being the corrected response. We then click on Statistics, click on chi-square, and say Continue. And here are our results. Here is the contingency table that you've seen previously. Here's our 100 participants. 47 were in the poorer performing group, 53 in the upper group. 56 people answered the item correctly, with most of them, 32 of the 56, coming from the upper group. And in the last frame, we have the chi-square results, the chi-square being 6.131, and notice that it is not significant. That is, there's no significant relationship. There's no significant difference between the patterns of responses for the poorer and better performing students.